Hello everyone, my name is Him and I'm from Environmental Engineering and Management program. Today I'm going to talk about the enhance the rate of hydrogen release from ammonium borane by Cobalt copper. So let's talk about the background. Since hydrogen energy is expected as clean energy which can achieve carbon reduction, therefore the development of hydrogen energy can help Hong Kong government reduce carbon intensity and fulfill the Paris Agreement. There are numerous types of hydrogen storage material in fuel cell applications, and here some types are capable to storage the hydrogen. From the left-hand side, this is the magnesium hydride, and the absorbent like MOF and organic liquid, and the borane material. Hydrogen can be stored in different states, like air in atmosphere, compressed gas, liquid hydrogen, formic acid, and borane material, like ammonium borane. In this table, ammonium borane has shown it has a highest volumetric energy density, which is about 140, and the storage capacity, 19.6, and that's why we choose it as our hydrogen storage material. The principle to release hydrogen from ammonium borane is adding water to ammonium borane, and it will release 3 moles of hydrogen. In this reaction, there is a few technical challenge, and the first one is the high cost associated with precious metal nanoparticles catalyst. The second one is sluggish reaction rate by non-precious metal catalyst, and the third one is low stability and durability. To fix the technical problem, our solution is to develop a metal catalyst by using non-precious metal like cobalt and copper, and increase the absorption kinetics of substrate and higher the stability and durability. To develop a optimum catalyst, we use two single-atom catalysts, which is cobalt and copper, and the single-atom catalyst has been known to boost catalyst performance of many reactions using nanoparticle catalysts, such as electrochemical reaction, due to their higher surface energy and more efficient atomic utilization. Like the graph one, the particle size increased with the surface area and brought these benefits. To synthesize the cobalt-copper catalyst, the first step is to place the diisocyanide to muffle furnace in 330 degrees Celsius in 2 hours. Then we get the carbon nitride and we mix the cobalt and the copper agar through the ball mill process, and finally the mixture will place into tubular furnace to carbonize it under 800 degrees Celsius in 2 hours. Then finally the carbon nanotubes are formed, and the structure of catalysts are shown in SEM image. In this part, there is an interesting catalytic performance has shown that non-precious metal catalysts such as cobalt and copper, if they exist alone, the performance are not very well, but if they mix together, like cobalt-copper dual atom, it brought a synergy effect and showed a much better performance in reaction time, TOF, and specific rate. For the theoretical investigation, we calculate the optimized structure and illustrate the stimulation result in these two figures. Our preliminary study confirmed the modulations of the environment of single atoms active site to alter the electronic structure is a reliable strategy for boosting catalytic activity. Therefore, we use the cobalt-copper dual atom, and in these two figures shows it enhance the stability of the absorption state of ammonium borane onto the cobalt single atom site when compared with pure cobalt single atom site. Also, the cobalt-copper dual atom synergy is a promising approach to enhance the substrate absorption ability. In this slide, graph A shows our best performance is with the cobalt-copper catalyst and made under 800 degrees Celsius of carbonization. Also, in the right-hand side, graph B shows the best catalyst, as I say, exhibit a convoluted worm-like structure and show a successful formation. To test the cobalt-copper stability, durability, and recyclability, we keep run the experiment 30 times by adding ammonium borane continuously without filtering the catalyst. Cause the catalyst can be effectively separated from the solution by simple magnetic manipulation, like the top right photo, and the 30 times cycle result, it shows a decay after the 18 times cycles, but it shows it is a good result so far, and it shows it is recoverable and high stability and durability. In conclusion, we have successfully prepared a magnetically recoverable cobalt-copper catalyst which bearing the cobalt and copper single atom. Next, due to the synergistic formations of cobalt-copper dual atom single atom and highly dispersed cobalt-copper nanoparticles for ammonium borane activation, we can observe a fast kinetics for hydrogen production. Also, we can observe the high stability result, which is due to the presence of stable single atom, which can effectively activate the ammonium borane. Finally, this work was fully funded by Hong Kong University Grant Committee and wants to thank you for the student and research assistant for the experiment work.